Good morning to all my YouTube viewers. In this video, I like to discuss about uh, question number 18 onwards, NEET sample paper 1. Uh, Let us start from 18. A capacitor of capacitance C1 equal to 1 microfarad withstands a maximum voltage 6 kilovolt, while a capacitor of capacitance C2 2 microfarad withstands the maximum voltage V2, that is 4 kilovolt. What maximum voltage will the system of this capacitor withstand if they are connected in series? Here, most important point, that capacitor C1 can withstand maximum voltage 6000 volt. It means it can be charged. It can be charged to Q1. You can see C1 V1, it can be charged up to 6 millicoulomb. That is the maximum limit of that capacitor to be can be charged up to this value. It cannot be charged more than this 6 millicoulomb charge. That is the capacity, that is the maximum range of this capacitor. If we try to charge more than this amount, that capacitor will get damaged. Now for the capacitor C2, that is 2 microfarad, will hold Q2 8 millicoulomb maximum charge. Now when they will be connected in series, both the capacitor will have same amount of charges. Now from the given condition, it is understood that it can charge maximum up to 6 microcoulomb for each capacitor. If we go for higher higher amount of charging, then C1 capacitor will get damaged. So our limitation will be 6 millicoulomb. That should be the maximum range of charges in the series combination. When they are connected in series, charge is same, that is 6 millicoulomb. That means V1 dash will be the potential drop for the first capacitor, that is Q by C1, and V2 dash will be Q by C2. Now when they are connected in series, the potential drop will be sum of these two, that is V1 dash plus V2 dash. Now as we can see, V1 dash and V2 dash equal to Q 1 by C1 plus 1 by C2 will come. Substituting the value of C1, C2, we can get V sum of these two, that is V1 dash plus V2 dash, that will be V equal to 9 kilovolt will come. That will be the answer. You can see in B 9 kilovolt is given. Now come to next job 19. In the shown circuit, the reading of ammeter is same when both the switches are open and when both the switches are closed. Assume the ammeter to be ideal. The value of R satisfying above condition. Here we can see two switches are present, this one and this one. When both the switches are open, in that case, this is the cell having EMF 1.5 volt, and it is connected with the 300 ohm resistance. Now as these two switches are open, the circuit will be complete in this side. That means total resistance will be this one plus this one plus this one, 450 will be the total resistance. Supply is 1.5. That means current we can find out. That current will be 1.5 divided by 450 will be the amount of current, and that will show in the ammeter here. Okay. Now if we join this, if we connect this both the switches, what will happen? This will be a short circuit route. It will bypass this resistance. Current will flow through this cannot flow through this resistance. Current will flow through the short circuit route, that is through this switch, and it will be the circuit. I mean, current will go up to this, then it will divide into two segments, then it will complete the circuit like this. That means these two resistance will be parallel. That will be 100 R divided by 100 plus R. This R is unknown. We have to find out R. R should be such that the amount of current in the ammeter will be same. That is the given condition in the question. Now what will be the current under this situation? 1.5 divided by total resistance. These two combined will give 100 R divided by 100 plus R plus 300 will be the total resistance. So we can get this one. 1.5 divided by parallel resistances 100 R divided by 100 plus R plus 300 will be the amount of current, that is I2, this one. Now this current again divides in these two branches, and we are interested about this branch where ammeter is connected. So you know current divider, that is R divided by sum of the resistances, I mean R divided by sum of the resistances, that means 100 plus R into total current. Total current is I2. You have to multiply it by I2, and I2 already known, that is this one is I2, because 1.5 divided by 100 R divided by 100 plus R plus 300 is I2. Now from the given condition, this amount of current which is going to pass through this one will be equal to the when switches are open and current was passing through this. That means this current 1.5 divided by 450, it will be equal to 1.5 divided by 450. Now we can solve this expression. These two will get cancelled first. You can see numerator denominator same. Now you can simplify it. Once you can simplify, you can see R will come 600 ohm. In this question, answer will be C. Next question 20. The power and voltage rating of a heater is 1000 watt and 100 volt respectively. What should be the value of R in the given circuit so that heater operates with power of 62.5 watt? I mean, from this relation 1000 watt we can find out the heater resistance. That will be how much? V square by R equal to 1000. From this relation we can get V square means 100 square divided by 1000 will give 10 ohm. Heater resistance is 10 ohm. Now as heater resistance RH R suffix H is known. Now as rated, the heat dissipated, that will be 62.5 watt. So how much current will pass through this? What will be the potential drop across the heater? That we can find out with this. V dash square divided by resistance of the heater will be 62.5. That means potential drop across the heater will be 25 volt only. Now from this we can able to find out how much current is passing through the heater resistance. That will be 25 divided by its own resistance 10, it will give 2.5 amps. Therefore 2.5 amps currents passing through this route. Now we know that here 2.5 amps. Now potential drop is known, so we can find out this one also, because this R we have to calculate. Potential drop is that is 25 volt. So from here we can find out this resistance is given here. You can this resistance to know, that means 25 potential drop will be then the supply is 100 volt, then what is the drop here? 75 volt. Now we can find out the main current. 75 divided by this resistance 10, that means 7.5 amperes will be the total current, main current, 7.5 amperes, minus this heater root current through the heater, that is 2.5 ampere. That means remaining current will pass through this. Remaining current means here 7.5 minus 2.5, that means 5 ampere current passing through this, and resistance is R into I, which is 5 ampere, that is equal to 25. R into I will give, that means 25 divided by I is known 5 amperes, so R will be known, that is also 5. You can see this current is 5 amps and potential drop across the heater is 25 volt divided by resistance, because both are parallel. You can see here in the diagram is not given here. This the potential drop here and potential drop across the heater both are same, 25 volt. So as you know, this current through this route is going 5 ampere through R. So R 5 into R will be 25, R will be 5 ohm. So that will be the answer. You can see answer in C. Job number 21. It takes 16 minutes to boil some water in an electric kettle. Due to some defect, it becomes necessary to remove 10% turns of the heating coil of the kettle. After repair, how much time will it take to boil the same mass of water? Let us say H amount of heat was dissipated, heat energy released from the kettle. Now H equal to, we can write V square by R into T is the amount of heat energy in joules. Now after repair, its resistance decreases by 10%, that is R dash, and supply voltage is same, and time will be different, that is T dash. V square by R dash, and this will be T dash. As R reduces, T has to accordingly have to balance, I mean T will increase here. No, T will also decrease. As R decreases, this is directly proportional. Now you see from here we can write T dash equal to, we can R dash by R. It is directly proportional. I mean T decreases, I mean R decreases, T will decrease. Now R dash by R into T. Now all these data are available. R dash is 10% reduced, means this will be the present situation. That is point, say R is the actual value here, then this will be 0.9 R. This one 0.9 R or 9 by 10 R. So substitute here, time is given 16 minutes. Then simplify this, you will get 14.4 minutes. This is a simple job. Now come to next one, 22. A long wire carries a current of 20 ampere along the axis of a solenoid. The field due to the solenoid is 4 millitesla. The resultant field at a point 3 millimeter from the solenoid axis inside solenoid is, we know through the solenoid magnetic field acts along the axis of the solenoid, and that value is given here, that is 4 millitesla. And one here one current carrying wire is also present through which 20 ampere current along the axis. So it will generate magnetic field. We know when we are going to calculate magnetic field around the current carrying wire, we know that it will be tangential. Will be if we draw circle around it, if current goes away from the if it goes away from the person, circle will be clockwise. I mean tangent will give the direction, or if it approaches towards the observer, it will be anti-clockwise circle. Whatever may be, clockwise or anti-clockwise circle, it is perpendicular to the magnetic field which is passing through the coil. So they are perpendicular to each other. That is to be very clearly we have to understand. So these two vectors are perpendicular to each other. I mean magnetic field due to current carrying wire, and say this is a coil, and axial direction will be the direction of magnetic field which is through the coil, that is B1, and B2 will be perpendicular to them. That means they are perpendicular to each other. So what we can do, we can find out resultant, that is BR square equal to B1 square plus B2 square. You can see here, plus twice B1 B2 cos angle between them 90 degree. So this part will cancel, this part will cancel. Only thing B1 square plus B2 square will be there. Root under 4 milli Tesla square plus 4 by 3 square. It will give us, both has come in terms of milli Tesla. 4 by 3. We know that magnetic field due to current carrying, straight current carrying, V naught I by 2 pi r, that is known to us 4 by 3 milli Tesla. So resultant is this one, it will give 4.2 milli Tesla, which is the resultant magnetic field, and answer will be B for this particular job, 4.2 milli Tesla. Now next job, a mass of 50 gram of water in a closed vessel with surroundings at a constant temperature takes 2 minutes to cool from 30 degrees Celsius to 25 degrees Celsius. A mass of 100 gram of another liquid in an identical vessel with identical surroundings takes the same time to cool from 30 degree to 25 degrees Celsius. The specific heat of the liquid is, we have to find out specific heat of the liquid, and first one is water, second one is liquid, unknown liquid. Now rate of heat is same for both, dq by dt is same for, rate of loss of heat is same. Now what you can do, dq by dt, we know amount of heat, mass of water, specific heat of water. If it is in as it is given in terms of grams, so specific heat is taken 1, temperature difference 5 degrees Celsius, so it will give us 250 cal divided by 2 minutes means 120 seconds, so it will give us dq by dt is this one, 25 by 12 will come. Now for the second situation, when I mean second condition, that is for unknown liquid, delta q dash will be m dash s dash delta t. Now delta q by delta t will be 100, it is also equal mass 100, specific heat is unknown, what is required to find out, temperature difference also same 5 divided by same time 120 seconds. So equalizing these two, because rate of loss is equal, so we can get S dash will be 0.5 kilocalorie per kg, 0.5 kilocalorie, and this is 0.5 calorie per gram. Again this is divided by 1000, so it will go there, and this will become kilocalorie. So 0.5 kilocalorie per kg will be the answer for this particular job. You can see D is the answer, 0.5 kilocalorie. Now job number 24, a 50 Hz AC current of crest value 2 ampere flows through the primary of a transformer. If the mutual inductance between the primary and the secondary is 0.25 Henry, the crest voltage induced the crest voltage induced in the secondary is. Now here given it is crest value 2 ampere flows. Now if it is given something like this, that peak value, suppose the same problem given current of peak value 4 by pi amps, that means we have to take I equal to, as it is peak value, so we have to take this one 4 by pi is given, sin omega t will be there, differentiate this, rate of change of current will be available, and that will be 8 by time period into cos omega t will be the expression, and this will be the rate of change of current, and mutual EMF generated due to mutual inductance, that is M di by dt. From there we can find out if it is given peak value, but here it is given crest value. You can see here frequency is given 50, frequency is given in the question. You can see it is crest value, CREST, crest value 2 ampere flows. That means di by dt in this case will be rate of change of current will be 2 minus 2 ampere divided by T by 2. This will be the crest value when it will reach to in the secondary coil. In that case rate of change will be 8 by capital T will be the rate of change of current, that means 400 ampere per second. Now we know that EMF generated due to mutual inductance into di by dt, it will be 0.25 into 400 volts, I mean it will be 100 volts. If this problem is given in this form, that crest value of 2 ampere, then we have to solve in this manner. If it is given peak value, then what I have shown here earlier, that A sin omega t will be the expression. A will be given, peak value will be given, and from there after differentiation we can get it. Now here answer will be 100 volts. This one B will be the answer for this particular job. Let us come to job number 25. In LR circuit, the AC source has voltage 220 volt. The potential difference across the inductance is 176 volt. The potential difference across the resistance will be, we know that V square equal to VL square plus VR square. We know this for AC supply, as between inductance and resistance phase difference is pi by 2. So V square equal to R square plus VL square will be there. We are interested about VR square, that means V square minus VL square will be there, and both the data are available. V is given 220 volt square minus 176 volt square. The VR will be this one. They have given answer pattern in this form. You can see here D will be the answer for this particular job. Now next job, a copper wire of length 1 meter and a steel wire of length 0.5 meter having equal cross sectional area are joined end to end. The composite wire is stressed by a certain load which stretches the copper wire by 1 millimeter. If the Young modulus of copper and steel are respectively given here, and the total extension of the composite wire, we have to find out total extension due to that specific load. Now that means we can do in this way. Young modulus expression for Young modulus is known: normal stress by longitudinal strain, longitudinal stress by longitudinal strain. We can find out for copper how much stress, longitudinal stress has taken place, because both the wire will experience same amount of stress because specific load is there. and where mass is negligible. So we can have this type of relations. Sigma copper will be y into epsilon copper, and sigma copper Young modulus is given into epsilon copper is available. Delta copper is known, and length is 1 meter. That means epsilon is delta longitudinal strain, delta L by L. That both the data are available. So this after simplification we will get 1 into 10 to the power 8 Newton per meter square. That is the amount of stress experiencing on copper wire. Similarly, for steel wire it will have same amount of stress, and Young modulus and strain of steel, longitudinal strain. So here length is given but elongation is unknown. So what to do? Strain will be this type. Because y is known, epsilon for steel is not known, take it as a subject, and then 1 into 10 to the power 8 divided by 2 into 10 to the power 11 will come, and that will give 0.5 into 10 to the power minus 3. That is strain, and elongation is length of the steel wire is 0.5. So substitute here, we will get 0.25 into 10 to the power minus 3 meter is delta L steel. Now we have to find out total elongation of the composite wire, that is delta total will be delta copper plus, this is already known, given in the book, in the question paper, and delta L steel is available from here 0.25 into 10 to the minus 3 meters. This is millimeter, 0.25 millimeter. So initially copper is 1 millimeter and this is 0.25 millimeter, total is 1.25 millimeter, 1.25 millimeter. That is D will be the answer for this particular job. Now job number 27. Here the Earth's magnetic field lines resemble that of a dipole at the center of the Earth. If the magnetic moment of the dipole is close to 8 into 10 to the power 22 ampere meter square, then the Earth's magnetic field near the equator we have to calculate. Near the equator, I mean as it is near the equator, it is position is end on broadside on position. So we have to we know that this formula, that is B suffix H, we can write mu naught by 4 pi magnetic moment divided by R cube, when R is very large compared with the dipole. This will be the expression. Data are available. Mu naught by 4 pi, you can write 10 to the minus 7. Magnetic moment is given 8 into 10 to the power 22 over radius of the earth cube. We can write 64 into 10 to the power 5 whole to the power 3. Solving this, we can get close to 3 into 10 to the power minus 5 Tesla will come, or you can say 0.3 Gauss. It is answer will be 0.3. D will be the answer. You can see here D is close to that 0.32 Gauss. This will be the answer. Now come to next job, that is the radioactivity of a sample is A1 at a time T1 and A2 at time T2. If mean life of specimen is capital T, the number of atoms that have disintegrated in the time interval of T2 minus T1 is we can write like this. That according to question we can write that radioactivity of a sample A1 we can write N1 into lambda, because minus dN1 by dt will give you will give it that is activity, that is A1 equal to N1 into lambda. Similarly, for the second, for time t2, it will be A2 that is equal to N2 lambda. It is given in the question. A1, A2 is given in time t1, t2. So we can rewrite like this: A1 minus A2 equal to N1 minus N2 into lambda for t2 minus t1 time. For time t2 minus t1, t2 will be getted here. Now the number of atoms disintegrated in time t2 minus t1, we can write N1 minus N2 equal to A1 minus A2 divided by lambda, and where T we can write 1 by lambda we can write 1 by capital T, that is mean time, mean life. Now substituting here, we can get N1 minus N2 equal to A1 minus A2 into 1 by lambda is capital T. So A1 minus A2 into capital T will be the final expression. So answer for this will be C, A1 minus A2 into capital T. Now job number 29. The human eye can barely detect a yellow light 6000 angstrom that delivers 1.7 into 10 to the power minus 18 watt to the retina. Nearly how many photons per second does the retina receive? That means amount of energy which is coming through this light is h into nu. That is say each ray, I mean each photon, a quantum of energy, that is energy per unit time, that is 1.7 into 10 to the power minus 18 watt of energy per unit time coming to I. That means n into, we can write in this way, n into h nu. Each photon will contribute h nu amount of power. That means energy per unit time. If we multiply it by n, that will give n per unit time. I mean it will give this amount of wattage. The h nu is the energy and n is number of photons per unit time. So ultimately it will become power in the expression which is given here, 1.7 into 10 to the power minus 18 watts. Now as we know, h is known, c by lambda, c is known, lambda is given, so n will be known. N will come very close to 5 point something, that is 5.11 or something, that will be close to 5 photons, and the matching answer will be here 5. Now come to job number 30. According to Bohr's theory, assuming infinite mass of nucleus, the frequency of the second line of the Balmer series, we have to find out frequency of the second line of the Balmer series, and we know Balmer series it will come to second frequency, second line of the Balmer series. That means it will jump from n equal to 4 to n equal to 2. That is known as second line of Balmer series. This is known as this is n1, this is n2, this is n3, this is n4. When photon comes from electron jumps from here to here, it is second line of Balmer series. Now let us see We know that 1 by lambda is a general form, that is r Rydberg constant within bracket 1 by n1 square minus 1 by n2 square. N1 means here 2, it is here, and n2 means from 4. That means we will write like this, that is we are interested about frequency, so c into r, velocity of light into Rydberg constant within bracket 1 by 4 minus 1 by 16, that will come. Substituting all that given value, I mean we know this, all these data, velocity of light 3 into 10 to the power 8 into 1.097 into 10 to the power 7 within bracket this. Solving here we will get 6.16 into 10 to the power 14 Hertz. Exactly we have to know the application of the formulas, that is required here. I think you have understood here, and in the next video remaining part will come. Thank you very much to all of you.